Good evening, sir. Good evening, sir.
Good evening, everyone.
Good evening, sir.
Yeah, good evening. Just wait for 1 minute. Let everyone join.
Sir, today's physics, no?
Yeah, in the last class, I think we did bio. So today we have to do physics. Then the next will be chemistry. Then the next will be bio.
Okay,
So
sir.
today is physics, and we will continue with gravitation.
Sir, we were doing laws of Kepler.
Yeah. So yeah, we did Kepler's laws in the last class. I do remember that. And we did about the three laws. So can anyone state about the three laws of Kepler?
Sir, all planets revolve in elliptical orbits with sun at either focus.
Okay, so all planets revolve in elliptical orbit around the sun.
Sun at either focus, sir.
Yeah,
Sir, it
sun being
means the planets revolve on either side of the sun.
yeah. And the next one,
Sir, it's also known as the law of periods. Square of the time period of revolution is directly proportional to the radius.
cube of the radius.
Cube of the radius, yes, sir.
The square of the time period of revolution is directly proportional to the cube of radius. Okay. So that we call as the law of periods. And the last one,
The law of velocity. The aerial velocity of a planet is constant.
yeah, aerial velocity of a planet is constant. It means that the planet sweeps out equal areas in equal intervals of time, or the radius of the planet sweeps out equal areas in equal intervals of time.
Yes, sir.
Okay. So we continue here.
Yes, sir.
So these were the three laws of Kepler, and after that, we'll again understand the concept laid by Newton. So Newton studied about the laws of gravitation. He studied about the gravitation. So first of all, gravitation, if I want to define gravitation, I can say that it is the force with which all the objects in the universe attract each other. So irrespective of what particles they are made up of, okay, so all the objects in the universe, they attract each other with a force that we call as the force of gravitation.
Yes, sir.
Here we go. Now about the law of gravitation, see, it states that we'll study today the Newton's universal law of gravitation. This we also call as the universal law of gravitation or Newton's law of gravitation, right? So according to the Newton's law of gravitation, the force between any two masses. Okay. So here the concept is of the mass. The force between any two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance between them.
Yes, sir. Sir, can you repeat once?
Yeah, sure. I'm writing it also.
Yes, sir. Sir, he got these after Kepler's law.
Yeah, after the Kepler's law. So these are, I will tell you why these are called as why they are called as universal laws. Universal law of gravitation. So gravity, first of all, gravity is everywhere, whether it is inside the earth, whether it is at the earth or outside the earth. Okay, everywhere we find a force of gravitation. So according to the universal law of gravitation,
present everywhere.
Yeah, the force with which every object in the universe attract every other object is directly proportional to the product of the masses and inversely proportional to the so the force with which every object in the universe attract every other object is directly proportional to the product of the masses and inversely proportional to the square of distance between them. Also, another very important point is that it acts along the line joining the masses. It acts along the line joining the masses. So here we observe that the force with which every object in the universe attract every other object is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. So consider here two objects. Okay, so here we consider two objects which are separated by some distance. So let these two objects, they have masses m1 and m2. So here this is our mass, we call this as mass m1. Let this be our mass m2 and let the two masses be separated by a distance r between them. So here this is the distance between them, r. The distance between their centers is r. So now the force between these two masses will be, first point is that the force between the masses will be directly proportional to the product of the masses. So force will be directly proportional to m1 multiply m2. Okay. So see, what do we conclude from this? The force is directly proportional to the product of the masses. So let this mass m1 be doubled. If I double this mass m1, I double this mass m1 and I make the second mass as half. So do you think that there will be any change in the force between them?
Yeah, yes, sir. No, sir. No, sir.
No, there won't be any
Yeah,
change in the
because
force
it's the
between them.
product of masses 2 and 2 get cancelled, so M1, M2.
Yeah, so the product of the masses will still remain the same.
Yes, sir.
Okay. Then okay, what about this? If this one is, if the first mass remains is made 2m1 and the second mass is also made 2m2. So the both the masses have been doubled. Then if both the masses have been doubled, then
So it'll still be equal, no?
what will be equal?
No, sir. Sir, we can take.
Now see, the product of the masses will become 4 times.
4 times M1, M2.
Yeah. So it will become 4 times of m1, m2. So if either the if the masses are doubled, if the masses are doubled, then the force becomes 4 times.
4 times
Right?
m1 m2. Yes, sir.
Yes. So that means it becomes 4 times of the original mass. Can we say like that?
Yes, sir.
Okay. If either the if suppose both the masses are tripled, then what will happen if both the masses are
It
tripled?
will become 9 m1 m2. So it will become 9 times m1 m2.
Yeah, what happened?
Sir, if both the masses are tripled, it will become 9 mass
Yeah.
1 into mass 2.
Okay. Hemoglobin come back. Okay, so I think everyone has understood about the product of the masses, that the force between the force acting between the two masses, the force acting between the two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance.
Yes, sir.
The second point, he said that the force between the two masses is inversely proportional to the square of distance. So I write like this: proportional and 1 over r square. So the force between the two masses is inversely proportional to the square of the distance between. So if you increase the distance, the force will decrease, and if you decrease the distance, the force will
The force will
increase.
increase.
Okay, now see how it increases. Here I have force inversely proportional to r square. What will happen if the distance between them is doubled? What will happen to the
Then it
force?
will become 2r, no?
Yeah, if the distance becomes 2r, so what effect will it have on force?
Sir, it will reduce the distance of force.
It will reduce. So how much will it reduce?
Sir,
Like consider like this. Suppose here initially the force was equal to 1 Newton. Consider suppose we have F equals to 1 Newton initially, and if I have the radius being doubled, so what will be the new force?
sir, 2.
Sir,
No,
the force will increase by 1 by 4 times.
the force will decrease by 1 by 4 times. So force will decrease by 1 by 4 times. Got it? So the new force here will be now 1 by 4. Got it? This will now become 1 by 4 Newton, as it varies as the square of the distance. So the square of 2 is 4, and hence you will get the force as 1 by 4 Newton. Okay, what will be the force if the radius becomes r by 2?
Sir, r by 2. Sir, the force will come 2, right?
No, the square of this, you get, if you square this,
Sir,
you get r.
r square by 4.
Sir,
So 4
increases by
Newton.
4.
So what will be the force?
4 Newton.
Sir, 4.
4 Newton. Got it? So the force will become 4 Newton.
Sir, actually, won't it be 2?
No, it won't be 2. It becomes 4 times.
Okay, sir. Sir, because it's r square, no?
Yeah, it varies inversely as the square of r. So you
Okay.
have to make
I
the
got
square.
it, sir.
Okay.
400.
Okay, what will happen if the distance is made 3 times of r?
Sir, 3r.
Yeah, so what will be the
Sir, 1
force?
by 9. 1 by 9 Newton.
1 by 9.
Yeah.
Everyone is getting? Everyone, I'm not getting answers from everyone. Sampath,
Yes, sir.
Pranav, Yukta, everyone should be answering.
Yes, sir.
Okay.
So become an active participant and obtain your answers. So okay, here we observe that if the distance becomes tripled, if the distance between the masses becomes tripled, The
Then it
force
becomes
between,
1 by 9. The force will become 1 by 9.
yeah, the force will become 1 by 9. And what will happen if the distance between them is reduced to 1/3?
Sir, 1 by 3.
Sir,
Distance is
it
1
is
by 3.
9.
So what will be
9
the
times.
force? 9 times. Got it?
9
The
times.
force will become 9 times. Okay.
9 times.
Everyone understood this?
Yes, sir.
That force is directly proportional to the product of the masses and
And
it is
force is
inversely
indirectly
proportional to the
proportional
r
to the
square.
square of distance between them.
Okay. So now try to solve this question based on these two concepts. I'm giving you one question here.
Sir, one question.
Yes.
No, yes, sir. Sir, based on both the formulas.
Yeah, based on both the formulas, I'll be giving you here a question. Try to solve this. Okay. So two masses have gravitational force between them.
Sir,
Yes.
what if the radius is doubled?
Yeah, if the radius is doubled, so the force will become 1 by 4.
Means,
Yes. Like
sir,
see, means here, suppose consider initially the force was, let's say, 10 Newton. Okay. Consider the initial force between the two masses was 10 Newton. And if you double the radius, so doubling of the radius means you have to square 2. Square
Sir,
of 2 is
1
4.
by 100 Newton.
So it will be 10 over 4, that is 2.5 Newton.
Oh.
Got it? It will be reduced by a factor. Anyone still needs explanation for this?
sir,
Yes,
what
anyone?
is one? Sir, you wrote F is proportional to 1 by r square. What is that? Is it 1?
It's proportional to 1 by r squared. That means f is inversely proportional to r squared. See, proportionality means if one of the quantity, we have two types of proportionality. Like we can have a direct variation or an inverse variation, right? A direct variation is a variation where if one of the quantity increases, the other one also increases. That we call as the direct variation. Then we have inverse variation. So in the inverse variation, if one of the quantity increases, the other quantity decreases. Got it? So here, the force between the two masses is it decreases as the square of radius. If the distance between the two bodies becomes 4 times, the force will reduce by 16 times. Got this?
Got it, sir.
Like if the distance between the two masses reduces by 4 times, or distance between the two masses increases by 4 times. Okay, so instead of r, it becomes 4r. So now the force between them will reduce to 1/16. Got it?
Yes, sir.
Okay, now try this question. Two masses have gravitational force between them. Gravitational force of 100 Newton between them.
Okay, sir.
What will be the force between them if if one mass is doubled and second mass is tripled, but the distance between them is also doubled, is also tripled. So find out the force between the two masses.
Sir, both the formulas have to be used, right?
Yes, you have to use both the formulas.
Will the force be 150 Newton?
Force will be
150 Newton.
1 over 50, 150
No,
Newton.
sir. 150 Newton.
Okay. Okay. So let's see. So I can obtain, let's say, the variation of force. So force is proportional to M1 multiply M2. Is there anyone who has got the answers? Anyone who got the answers?
Sir, can you once explain? It's a bit confusing.
So that's why I gave you. Okay, you can take the help of the previous one. Here you can see this
Sir,
one.
I'm getting 100 by 9, but
Getting 100 by 9.
yes, sir. Oh, 1 second, sir. I got it. 1 minute.
Sir, can we write it as M1 M2 equals to 1 by R square?
Okay. Okay. So see, we combine both of them. Since here we have the combined thing, so we combine both of them, or you can solve them individually also. So if I combine both the proportionalities, I get F proportional to M1 M2 over R squared, right?
Yes, sir.
So then I put the value of M1 and M2 here. Here it's given the force as M1 M2 over R square. Now let the new force be F dash, and I can write new force to be equals to, see, what will be the force between the masses if one mass is double and the second mass is triple. So now I will write, instead of M1, I will write here 2M1, and M2 I will write it as 3M2, right? Divided by R squared. So R is tripled. Instead of R, I write here 3R whole squared. So now the expression becomes, I have F dash proportional to 6 M1 M2 over 9 R squared. So this cancels 2 over 3. Okay. Now you can divide these two. This is your expression 1, this is expression 2. Divide expression 1 by expression 2. You get F over F dash to be equal to, here all M1, M2 and R squared, they get cancelled. So you have 1 divided by 2 by 3. 1 divided by 2 by 3, like this. So F dash will be equal to 2F over 3. Will be equal to F dash, that is the new force. So you have 2 by 3 multiply of F, which is 100 Newton. So you get 200 by 3. 200 by 3 is 66.7 Newton. Got it? Just have a look at it. I'm giving you one more question for your practice. Sir, kita mengajar. Sir, kita mengajar. Sir, kita mengajar. Sir, kita.
Sir,
Yes.
sir, if we are getting 1 by 2 times 3, then we have to get 100 times 3 by 2, no, sir?
100 times 3 by 2. No.
Sir, can you explain the last after expression 2?
Okay, see. If you get here 2 by 3, right? F by F dash equals to 2 by 3. Here I am getting 2 by 3.
Yes, sir.
So F dash is 2 by 3. So I'm getting here 2 by 3. 1 minute. Okay, so this is what you say. Instead of writing like this, if I write here 2 over 3. So if I simplify it, 3 will go to the numerator, or you can just cross multiply it. You will get the same expression as I have obtained over here.
Okay, sir.
Okay. So let's see one more question now. Find the force between them if their distance of separation is increased, if their distance of separation is increased to 4 times. So now the question is something like this. It should become easy now. Try to find out this one. B both the masses are tripled. If both A and B are done. Okay. So now find out the answer for in this way.
Sir, if both A and B are double,
Yeah.
sir, you wrote done.
Both the masses are tripled. Yeah, done. That means the part A and B both are done. That means their distance of separation is also increased to 4 times, and their masses are also tripled.
Yes, sir.
Yeah, so is there anyone who got the answer? Yes, is there anyone who got the answer? Okay, so let me solve it. I'm not getting answer from any one of you.
Sir, solving, sir.
Okay, so okay. Pranav, Yukta,
Yes, sir.
did you get the answers?
Sir, I'm the last one. I'm just solving it.
Okay. So you can check your answer for the A part. For the A part, your force is directly proportional to M1, M2. Since both the masses are tripled, so since force is directly proportional to M1, M2, so if the masses are tripled, so you will have force proportional to 9 times of M1, M2. So that means the force increases by 9 times. Okay, and hence your new force F dash would become 150 multiply 9. Okay, so it becomes
4-1.
1350 Newton.
50. By 16, right, sir?
Yeah,
By 16, no, sir.
yeah. Oh, sorry. This one I've done part B. So this is your for part B. For part A, it's the distance of separation.
1
Here
by
you
r
find
whole square, which is
F
16.
proportional to 1 over r squared. So
Which
the
is
distance of
4r
separation
square,
has
sir.
increased to 4 times. New force F dash would becomes 1 over 16 times of F.
9.3, sir, new one will be 9.37.
So this new force would be equals to 150 over 16.
So 9.375.
Okay, 9.375 Newton.
Sir, 1350, no, sir.
Yeah.
Oh, never mind, sir. My bad. 9.375.
Now, if I combine both the factors, so if I combine both the factors, then I will be getting the new force F dash will be equal to 1350 divided by 16. So this will be the new force. You can divide 1350.
Sir, 84.375.
83 point.
84.375, sir.
Yeah, 84.375. Okay, so is there anyone who has still not understood?
No, sir.
Yukta, Sampath, have you understood?
Yes, sir.
Yeah, Pranav, did you get the same answer? Pranav? Pranav? Harshit?
Yes, sir.
Okay. So I think Pranav is not responding. Pranav, if you don't send any replies, I'll just message in the group. Okay.
Sir, we can't combine both the things, right? Like make it M1 by M1, M2 by R whole square. Can we also solve like that?
Yeah, we can combine it together. So you'll get this one only. 84.375 will be the answer.
Okay, sir.
Okay.
Sir.
Is there any disturbance coming?
No, sir.
Just 1 minute. Let me try something. Okay, is it okay now? Okay. So let's do this one more question.
Okay, sir.
Okay, so we'll try one more question based on this.
All right, sir.
The force between two masses is 160 Newton.
Yes, sir.
What will be the force if one mass is doubled? The other is tripled and distance is reduced to 1/3.
Got it, sir.
Solve it.
Sir, 1 minute. Solving. Uh, B and
Anyone got the answer?
1 second, sir.
The new force will be 106.6 bar Newton.
How much?
Sir, 106.6 bar.
Sir, I got 8,640.
Yes, that's the correct answer. Okay. The force between the two masses will now become 8,640 Newton. See? See
Sir,
here it is a combined
sir,
effect of,
the radius is reduced 1/3 means it will be reduced 1/9 also.
yeah, so force will be increased by 9 times.
So it's the
So you have
160.
F proportional to m1 m2 over r squared. So here the new force F dash becomes proportional to m1, which is 2 times of m1 multiplied 3 times of m2 divided by 3r whole square. Not 3r, it's 1/3 r divided by r by 3 squared. So you have F dash proportional to 6 m1 m2 over r squared by 9. So r squared by 9, 9 will go to the numerator, and hence F dash will be proportional to 9 times of m1 m2 over r squared. So since the proportionality for m1 m2 by r square is 160, you get our F dash to be equals to 160 multiplied by 54. 9 multiply 6, that is 54. So you get here 54. You multiply it and you get 8,614. Got it, everyone?
Yes, sir.
Okay. Okay, so by all of it, we'll continue with this in
Yes,
our
sir.
next class.
Yes, sir. Thank you, sir.
Okay, bye. Raja ji. Hey, Raja ji.